Welcome to the DIY Honda Garage channel. DTC P16E3 refers to a specific diagnostic trouble code indicating a LIN, local interconnect network, communication error concerning the battery sensor in the powertrain control module, or PGM-FI, programmed fuel injection system. This error can impact the vehicle's performance, as the battery sensor plays a crucial role in monitoring the battery status and communicating vital information to the PCM. The battery sensor is typically located near the vehicle's 12-volt battery, where it connects directly to the battery terminal. When this component fails or experiences a disruption in communication, it can lead to several issues, including problems with the vehicle's electrical systems. In this troubleshooting guide, we will explore the causes, related symptoms, and step-by-step instructions for identifying and resolving the issue at hand, helping you restore full functionality to your Honda Fit. The P16E3 error code pertains to an issue with the PGM-FI system that specifically involves the battery sensor. The battery sensor is a critical component that monitors battery voltage, state of charge, and other parameters essential for optimal vehicle operation. Its communication with the PCM via the LIN protocol is vital. Any errors in this communication can cause the PCM to misinterpret the battery's condition. This sensor is generally positioned adjacent to the 12-volt battery, connected to the negative terminal, and linked to the PCM through a wiring harness. By relaying real-time information about the battery's performance, the battery sensor enables the PCM to make informed decisions affecting engine management and fuel efficiency. A malfunction in this system can lead to various operational problems, necessitating thorough investigation and remediation to ensure reliable vehicle performance. Several potential causes can lead to the emergence of DTC P16E3. First and foremost, loose terminals on the 12-volt battery sensor can disrupt the communication line between the sensor and the PCM. Similarly, damaged or frayed wiring in the LIN communication line may lead to poor connectivity and signal degradation. Additionally, a faulty battery sensor itself could be at fault. If the sensor fails to operate correctly, it won't send accurate data, leading to communication errors. Lastly, issues with the PCM, including outdated software or internal faults, may also be involved in triggering this diagnostic code. Each of these potential issues requires careful inspection, as identifying the exact cause is critical for an effective resolution. When DTC P16E3 is present, various symptoms may manifest in the vehicle's performance. One of the most common indicators is the illumination of the warning lights on the dashboard, alerting the driver to potential electrical issues. Furthermore, performance problems can occur, as the vehicle may experience poor acceleration, engine stalling, or difficulty in starting. In some cases, the driver might even notice a lack of accurate battery voltage readings, making it difficult to assess the electrical system's health. These symptoms not only impact the driving experience, but can also indicate larger, underlying issues that need to be addressed promptly to prevent further complications. The first step in troubleshooting DTC P16E3 involves verifying the problem through specific actions. Begin by turning the vehicle to the on mode, which powers up the electrical systems without starting the engine. Next, utilize the HDS Honda Diagnostic System to clear any existing DTCs from the system. After allowing a brief pause of approximately 10 seconds, recheck for any pending or confirmed DTCs using the HDS again. If DTC P16E3 is indicated, this confirms the failure, and you can proceed to the next step. However, if it does not appear, it suggests an intermittent failure, prompting you to inspect the battery sensor and the PCM connections for any loose terminals or wiring disruptions. In troubleshooting Step 2, it is essential to once again check for pending or confirmed DTCs using the HDS. This step allows the technician to assess if any related diagnostic trouble codes are present, specifically DTC P16E3, which indicates a LIN communication error associated with the auxiliary generator, ACG. If DTC P16E3 is indeed found, this necessitates your progression to a subsequent step in the troubleshooting process, focusing on the possible interconnected issues that might contribute to the overall fault. However, if DTC P16E3 does not appear, this indicates a different path of investigation, leading you to the next troubleshooting steps to pinpoint the issue more accurately. Step 3 requires the vehicle to be turned off, which allows for safer inspection of the components involved. Begin by disconnecting the 12-volt battery sensor 3P connector. With the connector removed, continuity testing can be performed by checking between two test points. Specifically, continuity should be measured between test point 1, which corresponds to the 12-volt battery sensor connector terminal number 3, and test point 2, which is the body ground. The objective here is to confirm that a clear electrical path exists. If continuity is verified, this suggests that the wiring is intact up to that point, prompting further investigation. If continuity does not exist, this points to a potential issue in the wiring, requiring immediate attention to avoid further complications. In this step, you will focus on isolating the LIN communication issue further by employing the HDS to jump the SCS, Service Check Short line. This action sets up the necessary conditions for testing continuity while systematically disconnecting various connectors. Begin with the 12-volt battery sensor connector's terminal number 3 and check for continuity to body ground as you disconnect other connectors in sequence. First, the alternator 1P connector, followed by the PCM connector A, 51P. The goal is to observe whether continuity ceases when one of these connectors is disconnected. If continuity is lost, this indicates that the wiring is sound, and further investigation can be directed toward the part that caused the interruption. If continuity persists, however, it suggests a short exists somewhere along the LIN communication line between the battery sensor, alternator, and PCM, requiring repairs to rectify the situation. Step 5 involves reconnecting the 12-volt battery sensor 3P connector that was previously disconnected. Once reconnected, you need to disconnect the alternator 1P connector. Next, it is essential to check for continuity between test point 1, which corresponds to alternator connector number 1, and test point 2, the body ground. This step verifies if the circuit is functional. If continuity is confirmed here, it indicates that the 12-volt battery sensor is likely faulty and thus necessitating its replacement. Conversely, if continuity fails to be established, this suggests that the wiring may be compromised, leading you to the next steps in troubleshooting the issue more closely. At this point in the process, you'll once again jump the SCS line using the HDS to set up optimal testing conditions. Following this, disconnect the 12-volt battery sensor 3P connector and the PCM connector A, 51P. With these disconnected, you can now check for continuity between test points, specifically between terminal number 3 of the 12-volt battery sensor connector and number 26 of the PCM connector A. This examination verifies the integrity of the LIN communication line. Should continuity be present, it indicates that the LIN battery sensor wire remains intact. When this occurs, consider whether the PCM has outdated software. You may need to update the software or substitute it with a functioning unit, which could potentially resolve the DTC P16E3 issue. If continuity fails, however, Repairs will need to be made to address an open circuit in the LIN battery sensor wiring before proceeding with any other actions. In Step 7 of the troubleshooting procedure, start by turning off the vehicle to ensure safe inspection. The next action is to check fuse number B18, which has a rating of 10 amperes and is located within the underhood fuse and relay box. This fuse is essential as it protects circuits associated with the battery sensor. If the fuse is found to be operational, you can confidently proceed to the next step in troubleshooting. However, if the fuse has failed, it indicates a potential short in the +B horn wire, which must be repaired, and the damaged fuse should be replaced with a new 10-amp fuse in order to restore proper electrical integrity. Step 8 requires further examination by first disconnecting the 12-volt battery sensor 3P connector again. This is crucial for safely measuring voltage between designated test points. Specifically, you should measure the voltage between terminal number 2 of the battery sensor connector and the body ground. Your primary goal here is to determine whether battery voltage is present. If battery voltage is measured, it indicates that the +B horn wire is functioning correctly. However, if battery voltage is not present, this suggests an open circuit within the +B horn wire, necessitating repairs between the battery sensor and the associated fuse for full restoration of operation. In the final troubleshooting step, you will power down the vehicle again and jump the SCS line with the HDS as previously conducted. Once this has been completed, disconnect the PCM connector A, 51P, while ensuring that the 12-volt battery sensor 3P connector is also detached. At this stage, continuity testing must be performed between the 12-volt battery sensor connector terminal number 3 and the PCM connector A, terminal number 26. If continuity is confirmed, this signifies that the LIN battery sensor wire is intact, indicating a need to replace the 12-volt battery sensor itself. Should continuity fail at this point, it suggests an open circuit condition exists between the 12-volt battery sensor and the PCM, necessitating further repairs to restore reliable functionality. Final repair verification is a crucial phase in the troubleshooting process for DTC P16E3. Once all necessary repairs have been conducted, verify that they were successful by monitoring the vehicle for any recurring DTCs. Use the HDS to perform another scan of the system to ensure that DTC P16E3 is no longer present. Additionally, it's important to conduct a road test to assess vehicle performance, paying close attention to any previously experienced symptoms. If the vehicle operates without issues and the DTC does not reappear, this indicates that the repairs were effective, marking a successful resolution to the problem. To help prevent the occurrence of DTC P16E3 in the future, it is essential to incorporate some preventive maintenance practices. One of the most effective steps is to regularly check the connections at the battery sensor to ensure they are secure and free from corrosion, which can impede communication. Inspecting the integrity of the wiring that connects the battery sensor to the PCM should also become a routine part of your vehicle's maintenance regimen, detecting any issues before they escalate into major problems. Additionally, it is prudent to ensure that the PCM software is updated regularly, enhancing communication efficiency and potentially preventing associated error codes. By adhering to these practices, you can improve the overall reliability and performance of your vehicle's electrical system. In conclusion, DTC P16E3 signifies a LIN communication error linked to the battery sensor within the Honda Fit's PGM-FI system. Accurate troubleshooting is imperative for identifying the root cause of the problem, which may involve various steps, including checks of battery connections, wiring integrity, and component functionality. By following the outlined procedures methodically, technicians can effectively diagnose and rectify issues related to this DTC. Additionally, Incorporating preventive maintenance practices can significantly reduce the risk of future occurrences, ensuring consistent vehicle performance. Proper attention to these elements ultimately contributes to a well-functioning Honda Fit, providing peace of mind and reliability to its owner. Please like and subscribe to the channel. See you next time.